All right, so let's go ahead and talk about the method getNum. So this is going to return the new num, which is a local variable, string data type, in the new base, okay? And that's given as a parameter. So we're assuming that decval was assigned properly, and that's an int, and so therefore in base 10, which is equal to the string number in given base. And we want to convert it to the new base. So before we do that, let's do an example to make sure you understand the algorithm for this. Suppose that 345 is a decimal number. So this is 3 groups of 100, 4 groups of 10, 5 groups of 1. And we want to convert it to base 6. So we're going to go ahead and divide by 6. And let's just move this over a little bit here. Okay. And again, this is base 6. That's what we want to convert to. So 345 divided by 6 goes in 5 times. And 45 divided by 6, 7, 42, remainder 3. Okay. So we're going to divide and, okay, we get the quotient, and we're going to go ahead and put the remainder here. Okay. Then we're going to divide by 6 again. 57 divided by 6 is 9, remainder 3. 9 divided by 6 is 1, remainder 3, okay? And 1 divided by 6 is 0, remainder 1. So therefore, the number 345 base 10 is equal to, and this is, you're going to concatenate the number from right to left. 3, 3, 3, 1. So 1, 3, 3, 3 in base 6. So suppose we want to convert to base 48. And so now we're dealing with digits other than 0 through 9. So one of your test cases, we have 1024, base 7, is converted to base 48. So the first thing you're going to do is convert it to a base 10 number. And when you do, we've already implemented this method. And this is a method called convert to base 10. So we convert to base 10, and we have 361. And now we want to convert 361 to base 48. So here we have 361. And we divide by 48, and you can see it goes in 7 times. Okay, and the remainder is 25. And then 7 divided by 48 is 0. Remainder 7. Okay, so we're going to go ahead and think about concatenating. But 25, what we're going to have to do is convert to one of the alpha digits, right? And so this is base 48. And so that means that it could be either upper or lowercase. So let's think about 25. All right, so 25, just recall that uppercase A has the digit value of 10, and uppercase Z has the digit value of 35. So 25 is going to be an uppercase letter, okay? And so because 25 is in between 10 and 35, in order to get its ASCII value, because we want to convert the digit value to the ASCII value and concatenate the character, one of these letters, to the number, we're going to add 55, okay? And then that is going to be stored as a char variable, okay? Suppose that we've got the remainder of 7 here, okay? 7, we know, is going to be, between 0 and 9, and so therefore inclusive. So therefore, because the ASCII value of 0 is 48, if you had, say, 7, then you would add 48 to it to get 55, which is the ASCII value of the character 7. And then if you have a digit value, right, if the remainder is bigger than 35, you know it's lowercase, and so therefore lowercase a has a digit value of 36, right? And so you would add 61 to get its ASCII value, which if you print it, then would be printed the lowercase a, okay, and so forth. So if we want to encode this here, okay, I got started in the method called getNum. We've got this local string variable, and we want to make a copy of the instance variable decval. You don't want to modify this instance variable, so make a copy of the instance variable here, because you may want to refer back to it later. And then I'm going to create another local variable called char digit. Okay, and so this is going to just store the current digit as a char. So we're going to do the algorithm we talked about here. Let's see. This here where we just keep on dividing by that new base value. So if we go back, while temp is greater than 0, we're going to go ahead and divide by new base and store that in this local variable called a remainder. So if the remainder is less than 10, we know it's the digits between 0 and 9. So what we're going to do here is we're going to add, as we said, 48. And 48 is simply the char, the ASCII value of the digit 0. So I'm going to add 48 to it, or I just put 0 here. Okay, and if the remainder, if that's not true, if the remainder is less than or equal to 35, that means it's uppercase. So what we're going to do is assign char digit, okay, and we want to cast it as a char, the remainder plus 55, okay, and that is what we saw here. We're going to add 55 to it, and honestly, if you want, you can just add 48 if that makes more sense to you, okay. And then if that's not true, we know it's lowercase, so therefore char digit will be cast as a char, remainder plus 61, okay. So again, that's how we're going to cast this as get the ASCII value and then cast as a char, and we'll get that lowercase letter, okay. All right, and notice that this is basically the reverse of what we did here. Here we subtracted 48, here we add 48. Here we subtracted 55, here, right, minus 65 plus 10 is minus 55. Here we subtracted 97 plus 36, so we subtracted 61. Here we're adding 61 and adding 55. Okay, we're just doing the reverse. Then finally, once we are done, well, first we have to concatenate it, right? So we're going to go ahead and concatenate new num to new num, the char digit to the left of what's already in new num. Okay, and then we're going to go ahead and divide the temporary copy of that decval divided by new base. And then we're going to go ahead and return the new num here, right? And then in base, new base. So let's go ahead and run the program. And we've got a couple syntax errors. So 74, let's reverse that. Okay, let's run it again. All right, and I don't think I had any tests for this one. Did I? Let's see. I think I do actually. And we've passed all the tests. All right. All right, so I hope this was helpful, and I will see you all in class. Bye.